Okay, this is Professor Clark. I want to welcome everyone to our go-to training on the final exam. I have a copy of the final exam pulled up, and what we're pretty much going to do is try to go through as many of the problems as we can before um, we before the time elapses. Okay, so what I want to try to do as part of this process, instead of me going through the problems and just giving you the answers, what I want to do is just take each problem at a time, and I want to see if you guys can solve it. Then after you guys provide your answer in the chat box, then I'll talk about how the problem can be solved and provide you with the answer. Okay, so our first problem states that we need to find the slope of the line graph below. Okay, so I want you guys to see if you can find that slope, and then I want you to type it into the chat box. Okay, Joe has -4/3. Okay, what about everybody else? Okay, if you need more time, type in "need more time." If you don't know, okay, type in "I don't know." Okay, so what about everybody else? Okay, so we got two responses so far. Okay, Paula, what do you think? Okay, so we're still waiting for. Oh, we got, okay, so we got a response from everybody. Okay, so there's a two ways you can do this problem. The first way you can do it is find out the coordinates for both ordered pairs. Okay, so the first coordinates are going to be x is going to be -3 and y is going to be 1. Okay, and then for the second ordered pair, x is going to be 1 and y is going to be 4. Okay, let me see if I can pull up and show you how I'm doing that. Let's see. I need to be able to draw something here. Layout. I need a pen. I need a pen. A pen. Pen. Let's do this. Applications. Let me find something like Sketchpad. Sketch. Sketchbook. Don't seem to see. No, that's not gonna do it. I need something that will allow me to draw. I had Sketchpad in here once upon a time. Let's see. I need something that's gonna help me draw. Keynotes, iTunes. Let me go to the App Store right quick. Sketch. I had Sketchbook in here, but now it disappeared. Sketchpad. Let me go to Sketchbook. If not, I'm gonna have to try to wing it with Word document. Go to Sketchbook. Okay. So the first thing we had to do, I'm getting there, so you guys be patient with me. It's gonna take a second for that to come up. Okay. Figure out. Open. It doesn't seem to want to open. I know there's something else on here that'll allow me to draw. Well, let's see. Paintbrush. Here we go. Let's try Paintbrush. Okay, so we'll go. I wonder why the paintbrush won't work. Ugh. All right, well, let's do this right here to see how we can do it a different way, because this process doesn't want to work for me. Okay. And I'm really disappointed that I can't seem to get a what's call them in. Okay, so we look at the number line. I'm still fixated on this why I can't get let me go to the internet and see if I can find a sketch book there so I can show how to do this problem. Sketch. Only place it seems somehow it seems to be a Murphy's Law day. Everything I'm trying to do, nothing wants to work. Okay, well, I don't know. And then the internet seems to be dragging slow too. All right, so we're gonna have to stick with this one route then. Well, no, it's not gonna be negative. Um, One of the things that we'll look at, we're gonna see that it's positive. Okay, and what's gonna make it positive is because uh, the line is actually going, the line is actually going up. So that's going to make it positive. Now, the -3 comes from because it's right underneath the dot at the -3. And then if you look to the side of the dot, you can see the 1. You know, I'm trying to see text selection. Um, mm, no, no. Okay. Okay, I'll have to figure that out some other time. Okay, so these are the ordered pairs, -3 and 1, because the dot's right up under the -3. And if you look to the right of it, you can see the 1. And then, okay, thanks, Joe. Maybe this will work. Okay, thanks. Okay, thank you. Okay, so here we go. Okay, so we've got -3. So one of the dots, okay, so we're going to put a -3 here. And then the dot's going to be about right here. And then we're going to put a 1 here for the y value. Okay, so that's where that -3 and 1 are coming from, because the dot is lined up right up under the -3 for x, and it's right beside the y for 1. Okay, and then when we look at our next value, we're going to see that we're going to put a 1 in for x here, and then we're going to put a 4 in for y. And so then that other dot's going to be right here. Okay, so this is where we're getting the -3 for x and the 1 for y. And then here, this is where we're getting the 1 for x and the 4 for y. Okay, so that's where those values are coming from. Okay, now I'm going to go ahead and draw the line. Okay, we can see when we follow that line from the left to the right that it's actually going up. Okay, now one way to trace this and figure out, what the distance is we can do it from the graph. We can just go from this point to that point and see how many spaces we went from -3 to 1. And see, from -3 to 1, we went over 4 spaces. Okay, because if you start at -3, -2, -1, 0, and +1, that's going to be 4 spaces. And then if we go up from 1 to 4, that's going to be 3 spaces. Okay, so we went up 3. So our slope is going to be 3 over 4. Okay, so the final slope is going to be 3 over 4. Okay, so now that's one way we can find the slope is through the graph. Okay, we go over 4 for x, and we go up 3 for y, so it's going to be 3/4. Now, when we look at the slope, the way we look at the slope, it is the slope equals the rise over the run, or the change in y over the change in x. Okay, so that's what we're talking about with the slope. The rise over the run, or the change in y over the change in x. Now, another way we can find the change in y over the change in x is we can subtract. Okay, we have a formula that says that the slope, and I'm going to call the slope m, equals y1 minus, we'll say y1 minus y2 divided by x1 minus x2. Okay, so that's going to be our formula. So what I'm going to do is I'm going to take I'm going to start off with that first value there, and I'm going to say that, okay, y is 1, and then for that second one, x is 4. Y is 4, and then I'm going to divide that by, I'm going to have x is -3, and then y is 1 in that case. Okay, so then I'm just gonna subtract. 1 minus 4 is gonna give me -3. Okay, and then -3 minus 1 is gonna give me -4. Now, anytime you divide two negatives, your answer is automatically gonna be positive. So -3 divided by -4 will give us a positive 3/4. Okay, and if we actually divided it, then our calculators would make it, a positive 0.75. And then we could convert it back to a fraction, and we would see that it's also a positive 3/4. Okay, so those are the two ways we can find the slope. We can either use the formula, look at the change in y over the change in x, and it doesn't matter whether it is, let me put that in. It doesn't matter whether it is, uh, let's see, y2 minus y1 over x2. No matter, which order you put it in, you're still going to come up with the same answer. Or the other one, I wanted to put them right next to each other. So I know I'm being finicky right now, but I'm going to do it because I just wanted to put them right up under each other so we could see it. Okay. I don't know if it'll let you go down and do that. Yeah, and that's the other one. So it doesn't matter whether you do it either way, whether you take the first one and subtract the second one, or you take the second one and subtract the first one, you'll still come up with the same answer. Okay, in fact, I'll do that. Okay, so in the second one, if we had to start it off with 4, okay, minus 1, and then if we had to divide that by, okay, 1 minus -3, Okay, we'll come up with 4 minus 1 is going to give you 3. And then, of course, I'm going to stretch it out a little bit. 1 minus negative 3 is the same as 1 plus 3, which would then end up being 3 over 4. So you still come up with 3/4 either way. Okay. Now, watching that slope, you can see it increase. Okay. So let's see here. I want to clean this. How do we clean it? Clean it. Clean it. There we go. Nope. Okay, I got to figure out how to clean it now. Okay, so figuring out how to clean it. Yeah, if you just always count over, if you always just go over for, if you always just go over for X and go up for Y, you'll always come up with the right answer. Okay, so now I'm cleaning it. When I finish cleaning it, what I want to do is I just want to kind of show you a few of the slopes that you might see. Okay, so let's see. I want to get a pencil. Okay, so let's see. Okay, so that's Y and that's X. Okay, so that was going up. Okay, so this one's going up. So when it's going up, it's always going to be a positive slope. Okay, so that means your answer is going to be positive if it's going up. Okay, and these things, they won't give you the answer, but they'll give you a framework for what your answer, could be, and so you'll kind of know if you're coming up with an answer, whether that answer is right or not. Like you'll look at it and you say, okay, you know, this line is going down, so I know my answer is automatically. I know my slope's going to be negative. Okay, so that was going down. So when it's going down, the slope's automatically going to be negative. And if we have, okay, so I'm gonna give us another one. This one's gonna be like, it's gonna be flat. Okay, so I'll put it down here somewhere. Okay, so flat equals a zero slope. Okay, and then the last one I want us to see, last graph I want us to see is going to be, that's going to be a vertical line. Another word for flat can be horizontal. So we can say vertical. All right, that one's going to be undefined. That I think that vertical is CAL. I don't know why it's kind of vertical. It kind of is undefined. That's going to be undefined. So we'll take flat out and put horizontal. So these are all the types of slopes you can see. Okay, you can see a slope that goes up, the answer is going to be positive. You can see a slope that goes down, the answer is going to be negative. You can see a uh, horizontal slope. The answer is going to be your slope is going to be 0. Vertical slope, your answer is going to be undefined. Okay, thanks, Joe. I seen that eventually. Okay, and I didn't put that in. Okay, so that gives us a point of reference to do the math. Okay, anytime you're working with math, you always want to kind of do your reading, and because the reading is going to give you a conceptualization of what a feasible answer looks like. So you look at it and say, okay, well, this is what an answer, looks like, or this is what the answers could be. So when we look at that graph and we seen that it was going up, that tells us that the slope is going to be positive. Now at that point, we got to figure out, how we got to move each way in order to get a positive or a negative slope. Okay. Okay. So, that's feeling. Okay. And the way we would check that, okay, we're gonna make that blue there, take a point there, and then we're gonna take a point here. Okay, so we're gonna put 2 points on the positive one. Okay, and then I'm gonna change it to red. So we would go over this away, and then we would go up. Okay, okay, and of course when we did that, we went over 4, and then we went up 3. Okay, and so that's how we came up with the 3/4. Okay, we went over 4 to get underneath the next point, and then we went up to reach the next point, and then that gave us 3/4. And we could do the same thing with the negative one. We'll put a dot here, and we're gonna put a dot here, and then we're gonna go down and then over. Okay, so you see how we went down here? We went down, okay, and then we went to the right. Okay, now notice, whether we're going up or down, we're going to the right. So your bottom number is going to always be positive, because here we went 4 right, and we went 3 up. Okay. Okay. And with the flat one, we're just always going over. Like, let's say, for instance, I'm going to make this blue and do the same thing here. Here we can see we just kind of, we just went over that way. So we didn't go up. So we'll say we went over 4. We went 4 to the right. And we went 0 up. 4 to the right, 0 up. Okay, so therefore, it's going to be 0 over 4, which is going to equal 0 for the slope there. Yeah, Michelle, the bottom number is always positive. And then if we looked at this one, we can say the vertical line. I'm going to move that one. And we're going to go here. And then here. Then we're going to go. We'll end up going we're just going to go up. So we're going to say we went up 5. 5 up. And we went 0 to the right. We didn't move to the right or left, 0 to the right. Okay. So at the end of the day, we went 5 up and 0 to the right. And of course, division by 0 is not allowed. So 5 over 0 is going to be undefined. And that's where we'll get this undefined answer from here. Okay. Okay, so that's it. Let me get this eraser. Erase. All right, back to black. All right, let me undo all this. I mean, it's a really cool application. I'm learning a lot from it. Okay. I'm trying to figure out how to get it to a point. Oh, to drag it over it. Just drag more key over all underneath. Yeah. Okay, so I'm gonna use the arrow. Okay, still not getting it. Okay, maybe that did it. I don't know. Okay. The first tool. Okay, so I'm taking that, selecting it, and drag all over. Okay, so the first tool. Joe, I'm kind of slow, so maybe I'll just do it like that. And then like that. I mean, you guys got to bear with me here. I'm going to learn more about this tool. Actually, I'm going to save it in my favorites. And I'm going to use it, moving forward when I have to, do stuff with the pen. But it's definitely much appreciated, Joe. Okay, so what we're going to do, we're going to move on to that second problem. Okay. And then the second problem states, okay, so here's the second problem. The perimeter of the rectangular painting is 360 centimeters. If the length of the painting is 96 centimeters, what is its width? Okay, so you guys see if you can do the second one. Now remember, just like the first one, if you don't know the answer, just say you don't know. Or if you think you got an idea of something that might help you solve the problem, you can ask me and then I'll say, yeah, that works. Okay, so Joe has 84 centimeters. Alan also has 84 centimeters. Okay, how about everyone else? What did everyone else come up with? Okay, so Paula also has 84 centimeters. Okay, does everybody else need time or do we not know? Okay, not a problem, Michelle. Okay, now we're going to need a formula. Does anybody know what formula we're going to use to solve this problem? Can someone give us the formula? Yep, that is correct, Joe. So we're going to say, uh, we'll say P, because that's what we're looking for, is the perimeter, times 2L plus 2W. Okay, so that's our formula. And then what we'll do is we'll fill in all the information that were provided. Okay, we were provided with the perimeter. They said that was 360 centimeters. So we're going to put that in. And then we were provided with the length of 96. So we're going to put that in. What we weren't provided with was the width of W. The question asked us, what is the width? Okay. Um, Always remember when we're solving for word problems, we need to figure out what the unknown is. Exactly what is it that they're asking us? And then that unknown ultimately is going to become a variable. Okay, in this case, that variable is W, and the W stands for width. Now, in the classroom, when we're not talking about anything in specific, we'll call the unknown X, and then we'll call the second unknown Y. But in the real world, when we're talking about something, we want to give the unknown a variable that's similar to what we're talking about. Like if we're talking about four chairs, if we were talking about chairs, we'll call the unknown C for chairs. If we were talking about pencils, we would call the unknown P for pencil. If we were talking about tickets, we would use T. If we're talking about distance, we use D. Okay, if we're talking about circumference, we use C. So that unknown letter is always going to represent whatever it is that we're talking about in the real world. Okay. The only reason why we use X and Y is because when we're in the textbook and we're just wanting to practice how to, solve equations, we just say, well, the unknown is X because we're not talking about anything specific. Now, from here, we got to do the order of operations. Okay, so we're going to use the order of operations to solve what we know. And so that means that we're going to do the multiplication of 2 times 96 first. So that's going to be 2 times 96. And then that's going to give us 192. So we're going to have 360 equals 192. And that's going to be plus 2W. Okay. And then from there, we're going to use the addition method to get rid of the 192. Okay, now why are we using addition? Because, 192 is adding to 2W. So the way we get rid of addition is through subtraction. So we're going to subtract 192 from both sides. And then if you subtract 192 from the addition of 192, that will get rid of the 192. Okay, and so when we do that, that's going to give us 168 equals 2W. Okay, because 192 minus 192 is 0. And then 0 plus 2W is 2W. Now we got to get rid of the 2 so that we'll have the W by itself. So the way we do that is we're going to divide both sides by 2. And the reason why we're dividing by 2 is because the 2 is multiplying. Okay, so in the end, that's going to give us 84. And then that's going to equal W. Now, of course, W is 1W. So 2 divided by 2 is 1. So that gives us 1W. Now, we just can't call it 84. We've got to say, we just can't say 84 like that. We've got to say that W equals 84 centimeters. So we'll say cm. So, I don't know what happened there. My intentions were to put one thing and another thing came up. Okay, so we'll say 84 cm. Okay, so congratulations to everyone who came up with that answer of 84 centimeters. You did an excellent job. You always have to list the unit of measurements because at the end of the day, when we write for other people. And someone who was not privy to this interaction would not know what we were talking about. 84 what? Do you understand that you were working with centimeters? And the only way they understand is if you tell them. So if you say 84 centimeters, they say, they got it 84 centimeters. Okay. When we're working with perimeter, it's always, 1 unit. When we're working with area, it's always squared. And when we're working with volume, it's always cubic. All right, we're going to skip number 3 because that's a checkbook problem. Okay. I think that's going to be pretty explanatory. And then you're just going to be filling out a checkbook. Let's see if we can do number 4. Okay, Alan has 36 people. Okay, Joe has 36 people as well. Okay, and Paula has 36. and so does Michelle. So that answer is going to be pretty, it's a good chance it's going to be right because everybody came up with the same answer. Okay, but let's look at it and see how it came about. Okay, so what I'm going to do is I'm going to break the sentence down into just the meat and bones. 30 people is 5/6 of the club. Okay, so this is the bare bones of the sentence. 30 people is 5/6 of the club. Now there's some key words in that statement, okay, that we've got to be able to identify and use. Okay, does anybody know what key words that are in that statement? 30 people is 5/6 of the club. That's going to let us know what, math symbols and operations to use. Correct, Michelle. Of means multiply. Okay. And Joe, what does is mean? What does the is tell us? So the of tells us to multiply, and the is tells us to do what? Okay. Not to equal, correct. Okay. So thanks, Michelle and Paula, for joining in. So that means to equal. Okay. So when we look at this, and we have this here, that word, so we've got 30, is means equal, 5/6, of means to multiply, and so I'm gonna put a different sign, and then of the club. And so in this case, the club is the unknown. That's why they're asking us how many people are in the club. Hence, we don't know. So I'm gonna call that C for club. So we're saying 5/6 of the club, and the club is unknown. The question tells us it's unknown. So that's going to be our variable. Okay. When we look at word problem strategies, one of the things that we know is we got to figure out what the unknown is, because that's what our variable is going to be. Okay, so that's our problem. 30 equals 5/6 times C, or 5/6 of C. Of means to multiply. From there, everybody knew that we could use the reciprocal, so we could go 6/5 times 30 equals, we're going to do the same thing on the other side, 6/5. Okay. And then it's going to be 5/6 here. And then we're going to put the times C. Okay. So in this case, the 6/5 and the 5/6 reciprocals always cancel out and make 1. Okay. With the 6/5 times 30, we can cross cancel. Okay. Everybody knows how cross canceling works, right? Okay, we've got 30 times 6/5. We cancel here. 30 divided by 5 is 6. And then we're ending up with 6 times 6 is 36. Okay, so in the end, we end up with 6 equals C. Okay, 36. I don't know. I don't want to put that in there for. I got 36 and then I put 6. Okay, so 36 equals C. Okay. Now, the reason why we use the reciprocal, because let's say if we take 5/6 like this, and then we multiply it by 6/5, we're going to cancel here. 5 divided by 5 is 1. 6 divided by 6 here is 1. And so in the end, 1 times 1 is 1. Anytime you multiply something by its reciprocal, it will always be 1. So that's why we're always choosing the reciprocal like that. Okay. All right, so that's that. All right, let's look at the next problem. Don't need that to do that. So, okay, so here's the next problem. Okay, so in this problem, they're wanting us to find the mode. Okay, so you guys see if you can find the mode, the mean, median, mode. But I think they only asked for the mode, but those three things normally go hand in hand. Mean, median, and mode. It's statistics. Okay, so Alan has 0, 1, and 3. Okay, Joe has 0, 1, and 3 as well. And Michelle, I'm taking that 0, 1, and 3 as well. Okay. Now, could someone give us the definition of the mode? Okay, when we say, find the mode, what does that word mode mean? Frequent, that's correct. It's the one that occurs the most frequent. Okay, it's possible to have more than one mode, as in this case. So I want to congratulate you guys. You were correct. There are 3 modes, 0, 1, and 3. It's possible to have, no mode. Okay, if none of the numbers are frequent, they don't repeat, then it's possible to have no mode. Okay, so great job finding the mode. All right, let's look at number 6. Let's look at number 6, see if you guys can figure out number 6. Okay, not a problem. Alan? Okay, so Paula has 28 minutes. Okay. Joe has 28 minutes as well. Okay, and so Michelle has 28 minutes as well. Okay, okay, so guys, what type of problem is this? Okay, what kind of formula do we use to solve this problem? What type of problem is it? It is a rate problem. It is. The type of problem we can say is DTR. Okay, it's similar to a DTR problem. Okay, that's distance equals time and rate. So, that's the concept we're going to use to solve it. It's going to be a DTR problem. So what we're going to say is we're going to say, okay, how do DTR problems work? You've got the distance equals the time and the rate. The times the rate. Okay, so that's what kind of problem it is. It's a DTR problem. Okay, so we've got some of the information already. Okay, now we don't have a consistent time because they're wanting to know how long does it take. So the time is going to be unknown. Anytime they say how long does it take, that's what they're wanting us to find out. So that's our unknown variable in this case. Our unknown variable is time. So we've got in the DTR, I'm going to put that down here again. What's unknown is the time. That's why they're asking about it. Okay, the question says, how long does it take? Okay, that's time. How long does it take? How many minutes does it take? Okay, if we knew that, then they wouldn't be asking the question. Okay, now they do provide us with times. They provide us with 44 minutes and 77 minutes. Okay, but it's obvious neither one of those times is the correct time for this situation because they're asking us about time. They wouldn't just ask and you can just say, oh, that's it right there. Okay. So what we're going to do is we're going to put in the information we know, and then we're going to figure out the rest. Okay, so we do know the distance in this case, and the distance in this case is not really a distance, it's a quantity. Okay, so in this case, it's going to be, so instead of saying it's a DTR problem, we could say, it's a Q equals TR, T times R. Okay. But we get the gist of it. It's the same concept. Okay. You multiply the times the rate, and it gives you the quantity, which is the volume of water in this case, which is liters. So we're going to say that the quantity in this case, which is the same as the distance, is going to be 7,700. Okay, and then that's going to equal the time and rate, okay, of the first tank. So I'm going to call that TR1. And then I'm going to add that to the time and rate of the second. Okay, matter of fact, I'm just going to put these in parentheses so I don't get confused with the plus. Okay. Okay. Now, the reason why I can get away with that because the problem says the time and the rate will give me the distance. Okay, so if I figured out one's time and rate and I multiplied them together, it would give me the distance for that one. And then if I found the time and rate of the next one and I multiplied those together, it would give me the distance for the second one. And then I could add those two distances together. Okay, now at this point, all I know is the quantity, which is like the distance in our DTR problems. I can figure out, what the rate is for each one. So what I'm going to do is I'm going to say, well, if the first one, pumped out all the water in 44 minutes, then I'm going to use that to figure out what that rate is. Okay, you know how much it can pump out. Okay, in 1 minute. So I'm gonna take 7,700 and divide it by 44. Okay, and then that's going to tell me what's going to happen in 1 minute. Okay, so indirectly they're giving me the information to figure out what that rate is. And then I'm going to take 7,700. I just looked at that number. I want to say it's 77. Yeah, it is 77. Divided by 77. And then that's going to give me my second rate. Okay. So when I take, and I'm using my calculator, I'm 7,700 divided by 44. That's going to equal 175. And so that 175 is really 175 liters, okay, per minute. So that's going to give me 175 liters per minute times the time. So I'm just going to say that's 175 T. And then that's going to get added to, and then when I take the 7,700 divided by 77, that's going to give me 100. And then that's going to be 100 T as well. So that's, you know, I'm talking 100 liters, you know, per minute. Okay, because that's the rate, 100 liters per minute, like 45 miles per hour. Okay, now I've got those two. Now at this point, this becomes an algebra problem. Okay, I go to the rules that I know about math. Okay, I know that when you got two variables, okay, and they have the same variable, that you can add them together. When they're alike, you can add them. Okay, so I'm just following math rules at this point, rules that I've learned about working with equations. So I'm going to take 175 and I'm going to add it to 100. And then that's going to equal 275. And that's going to be 275T. Okay, now, so together, they're pumping out 275 liters, okay, per minute. But I want to know how many minutes, all together. Okay, so I can take that. At this point, it's still algebra. I don't know what T is, so I got to solve for T by dividing both sides by 275. And of course, 275 divided by 275 is 1T. And then 1T can just be reduced down to just T. Okay, and so then we're going to take 7,700, divide 275 from it. And our final answer is 28. So you guys did an excellent job on this problem, the ones who came up with 28. Now we know that the 28, T stands for time. So the 28 is 28 minutes, because that's the time we were working with the 44 minutes and the 77 minutes. The rate was based on minutes, so the time that we're going to come up with in the end here is going to be based on minutes as well. Okay, so a great job on this problem. But we noticed how we took a concept that we were familiar with, which was the DTR problems, distance equals time times rate, and then we used it, except we just didn't call it distance because we knew it wasn't distance, we knew it was quantity. So we say, okay, DTR, QTR, same concept. And then we use what we knew about solving equations to finish this problem off. Okay. Okay, so let's look at the next one. Okay, now I'm going to set that next one up because I want you guys to see how it's done. I mean, you guys can't really do a histogram, okay, on the chat box. But let me ask you guys a question. What is the difference between a histogram and a bar graph? What is the difference between a histogram and a bar graph? Okay, that's definitely a honest answer, Michelle. Thank you. Okay, so Joe's saying that it's direct measurements for bar graphs. Yep, bar graphs are discrete. Okay, discrete is direct. Okay, they're just one specific number. You know exactly what you're talking about. Okay, and the histograms take into account intervals. Okay, so it's intervals of data. Okay, so you got discrete, which is, concrete, and then you got intervals, which is continuous. Okay, so it's different. Now, there's also a difference between the graphs, the pictures themselves. Does anybody know what the difference between the pictures is when you look at the picture of a bar graph and you look at a picture of a histogram? Okay, so Joe provided us with the information for, the definition, but what about the pictures? How do the pictures look different? Well, yeah, the bar graph is centered and it does include data. Okay, but how is it different than a histogram? You look at both of those bars. When you're looking at the bars on a histogram, you're looking at the bars on a bar graph. What difference do we notice? Well, they both have bars. Okay, so you're saying that the lines are continual for the bar graph or the histogram? Okay, so you're saying for the bar graph. Okay, let me do this. I'm going to draw you guys a picture of a bar graph and a histogram. And, this is not the one that we're using here, but I'm going to draw you a picture of both of them so you can see them side by side. And then you can see if you can observe any differences in them. Okay, let's see. Okay, so let's see. This one's gonna be and it's gonna be kind of like a rough shot of it. Okay, we're gonna put let's see, B, Y, and G here. Okay, we'll put 10, 20. Okay, and this could be our bar graph. And then I'm going to do another one over here. I'm going to put that same 10 and 20. Let's see, we're going to go right here, right here. And then we'll take this one all the way up. Like that. And that's going to be from 10 to 15. Then that one's going to be like from 15 to 20. And then we're going to go like from 20 to 25. Okay. Well, we can say, I will say 16 in here. And that didn't turn out right. So we go 10 to 15, 16 to 20, and then 21 to 25. Okay, let me scratch out of that. That was fun while I was doing it, but then it didn't turn out right. Yeah. And then the other one will go 16. Well, yeah, that's actually that is correct. I don't know what I was thinking. You know what? Watch this. I don't really have time for that. I got an eraser. Okay. All right, there we go. 10, 15, 20, 25. Okay. So what is the difference between the two? And this is a histogram here. When we visually look at them, how are they different? Okay, I think okay, so how do these things look different? Okay, that is correct. The bar is spaced out. So there's spaces between the bar graph. Okay, the histograms, the data is more continuous. Okay, do you guys observe another difference besides that one? Okay, what about the bottom with the x-axis? Okay, because we've got the y and then we got the x. Okay, what's one difference that we're noticing. Okay. Well, what are we noticing down here? Yeah, that's correct, Michelle, that the information is given in different terms. Notice on a bar graph, you can use qualitative data. Okay, they don't even have to be numbers, they can be words. Okay, histogram, the information has to be numbers because we're talking about intervals. Okay, so that's the difference between a bar graph and a histogram. When we're looking at histograms, because we're talking about intervals, we're going to have boundaries. We're going to have upper and lower boundaries. Okay, so let's look at the problem that we've been given, and then we're gonna just kind of figure out what's important in that information and how we can use it to create this histogram. Okay. Now, one of the things we can use before we create the graph itself is we can do a table. Okay, so we're going to look at the information that they're giving us. And what they're saying when we look at this is saying draw the histogram for these data using an initial boundary of 0.5 and an ending class boundary of 45.5. And then there are going to be 5 class widths. Note that you can add or remove classes from the figure. Okay, so to figure out, what is the interval, what is the distance between each class, and each class's distance is going to be the same, what we're going to do is uh, we're going to take the information that we know, and we're going to say, okay, well, we're going to start off with, we're going to say, okay, it says, um, when we look at it, it says we started off with zero point 0.5 and an ending class of 45.5. And so we need to figure out exactly how much distance that is that we're going to be working with. So what we're going to do is to figure that out is we're going to try to figure out the space in between. So we're going to say, okay, we're going to take the ending of 45.5. We're going to subtract the beginning of 0.5 because that's going to give us the range. And then that's going to equal 45. So that means between the first one and the last one is a 45 space difference. That's the interval between the first and the last. Then we're going to divide that by the amount of classes, which is going to be 5. And then that's going to give us 9 as our class width. So that means that from 0.5, to get to our next class, we're going to add 9 to it. Okay, so when we set up our table, when we say, okay, well, let's set up tables with our classes, we got 5 classes. So we're going to say, okay, well, let's look at our classes. So we've got classes. And then with our classes, that's going to be 0.5. And then to get to our next class, to get to the next boundary, we're going to add 9 to it. So that's going to be 9.5. And then that 9.5 is going to be here. And then we're going to add another 9 to that. And that's going to give us 18.5. Okay. Now, when we finish this, we're going to know the common theme between all of these categories is going to be 9. Okay, so now we're going to put 18.5. So if it's not 9, there's something wrong. 27.5. And then we're going to go 27.5. And then that's going to be 36.5. And then we're going to have 36.5. We're going to add, I don't know why I was getting ready to put that in the middle. No fair. It's going to be 45.5. Now, let's do some checking here. Okay, so let's look at some things. Okay, so let's take this 18.5 here and go down to the next lower limit. If we take 27.5 and we subtract 18.5 from it, if we take 27.5 and subtract 18.5 from it, that's going to equal 9. Okay, so let me do something here. Let's see. Now, what I want to do now is I want to take this class right here, 27.5 to 36.5. And if we subtract those two, 36.5 minus 27.5, that's going to equal 9 as well. So 36.5 minus 27.5, that's going to equal 9 as well. I want to do one more. Now, if we take the ending boundaries, let's take the 36.5 here and the 45.5 here. And if we subtract those, that's going to equal 36.5. That's going to equal 9 as well. Okay, so because the class width is 9, it's going to affect the intervals. It's going to affect the lower boundaries and the upper boundaries. Or with the lower boundaries, we can call those the beginning boundaries. And with the upper boundaries, we can call those the ending boundaries. So there's going to be 9 units between every lower boundary as we go up, and there's going to be 9 units increase between every upper boundary as we go up. And between the lower boundary and the upper boundaries for each class, there is going to be 9 units. Okay. Now, another thing that we can do to verify answers is that I'm going to do that. I'm going to count how many classes I got. Okay, so that's 1 class. That's 2 classes. That's 3 classes. That's 4 classes. And that's 5 classes. Okay, so that's 5 classes there, which is what we stated we had right here. We said that they were, now let me do this. We said that there were 5 classes of equal width at the beginning. So we can see that. So we set that. Okay, so we got the information. Now what we need to do is we need to figure out how many employees or how many units we have in each class. So we need to figure out what the frequency is. So what we're going to do here, let's see, we'll use a filler, black, somewhere in here. You know what, before I do the filler, I want to take out those numbers because we were just using that to verify. So we got that. So we're going to look at our frequency. Okay. Okay. And before the frequency, we'll put in tallies. The tallies is just to help us count them up. Okay, so that's the way we're going to do it. Okay, so the 7, okay. Yeah, Polly, it's going to be posted inside of YouTube. Well, that's a good question. Okay, so what we're going to do is we're going to look at the tallies to get this done. So we're going to say, okay, the first one is, that's not fair. Move that over a little bit. There we go. Okay, so the first one is 7. Okay, so 7 is in between 0.5 and 9.5. So we can scratch that one off. Then the 2. The 2 is in between 0.5 and 9.5, so we're going to make a tally there for that. The 37 is in that last class, between 36.5 and 45.5. The 32 is in between the second to last class. The 27 is in the middle class. The 22 is also in the middle class because 22 falls between 18.5 and 27.5. The 16 is in the second class because 16 falls between 19.5 and 18.5. The 11 also falls in between 19.5 and 18.5. The 6 falls in between that first class, the 0.5 and the 9.5. The 1 falls in that first class, 0.5 and 9.5. The 36 falls in that first class, now the next to last class, the 27.5 to 36.5. The 31 falls in that next to the last class too. It's in between 27.5 and 36.5. The 25 falls in the middle class. The 20 falls in the middle class. The 15 falls in the 9.5 to 18.5. Then the 34, we've got 2 of them, and they both fall in the 27.5 to 36.5. So one tally for one, another tally for the other 34. Then we've got 2 29s. Both 29s fall within that second to last class. So we're going to put in 2 tallies for that. And we got 2 24s. The 2 24s are going to fall in that 18.5 to 27.5. So we're going to make 1 for 5, and then we're going to be done. Okay, now the next thing we want to do to double check our work to make sure that we didn't miss out on anybody. The original problem says that there are 21 employees. Okay, so there's 21. So we need to count those tallies and make sure that there's 21 of them in our total. Okay, and the only reason why we're doing that is because we just want to make sure we got 21. Okay, so we've got 4 plus 3 makes 7, and then 7 plus 6 makes 13, and then 13 plus 7 makes 20, and then 20 plus 1 makes 21. Okay, so there's no bones about it. They're 20. We counted up 21. They said they were 21. We haven't missed out on anybody. Okay, now those tallies were just to let us, mark them as we were, putting them in the classes. So we got to look at those 4 tallies, and that's going to be 4 for the frequency. The 3 tallies are going to be 3 for the frequency. The 6 tallies, the 6 marks are going to be 6 for the frequency. The 7 marks are going to be 7, and then the 1 tally is going to be 1. All right, so that's our classes right there. Okay, so we got our 5 classes. We got the intervals for the classes, and we got our frequency 4, 3, 6, 7, and 1. Okay, so from here, we're going to go ahead and put our histogram together like that. Okay. Now we can go ahead and put our, we'll put 0.5, and then that'll go to 9.5, and then that'll go to 18.5, then that'll go to 27.5, and then that'll go to 36.5. I don't know why I just put that bar there, but I did it. And then the final one will be 45.5. Okay, so those are our intervals. Okay. Now from there, what I want to do is I'm going to put because I know everything. I'm going to put 1 here, 3 here, 4 here. Cause it's a small amount, so I can get away with this right here. They have to be the same increments. I'll jack up 6 a little bit higher, and then 7. Okay, so that first group, there's 4 in between 9.5. So I'm going to run that all the way up to 4 and drop it right here at 9.5. And then my next group has 3 in it, and then that runs out to 18.5. Now the spacing obviously isn't the way it's supposed to be, because I don't have like a ruler and I don't have graphing paper. So, and then from 18.5 to 27.5, that's going to be 26. So I'm just going to take that line and run it up to 6. And then I've got 7 for my next group. So I'm going to take that 6 and just run it up a little bit more. And then the last one is going to be 1. And that's it. Okay, and that's our histogram. Okay, so we got our frequency on the side here. That frequency in this case is employees. Let me put out a little bit more. So I'm saying employees here. And then the intervals, 21 employees of a certain, the distance traveled to work. So this is going to be, I can call it commute or distance. I'm going to call it commute, so because that's typically what we do when we go to work. We commute. I call that commute to work, just to label it. Okay, commute. Okay, commute. Let me put 2 in front of this. Commute to work. Okay. So that's how it's going to be set up. Employees on the left hand side for our y-axis, commute to work. On our x-axis at the bottom, notice that the histogram, the data is continuous. There is no spacing. We're using intervals. We've got uh, 5 classes, so we've got 5 bars. Okay, and the quantity on the frequency and the tallies are matching up with the quantity on the graph. So that's how we construct a histogram. All right, so here's another problem for you guys. Let's see if you guys can do this one. This is going to be like an odds problem. It says a bag with 9 marbles is shown. 4 marbles are white, 1 is gray, and 4 are black. A marble is chosen from the bag at random. What are the odds in favor of choosing a white marble? Okay, now odds are different than probability. Yeah, Michelle, that was detailed. Creating graphs are always detailed. A lot of times that's why they have computers that'll create those graphs for you. Okay, so for number 8, this is an odds problem. It's not probability. We do use probability to solve odds. Once you get familiar with the odds, though, you don't have to actually use the probability. You can still come up with the answer, but it is based upon probability. Yeah, it's favorable over unfavorable. Yeah, so it's the probability of favorable over the probability of unfavorable. Okay, so Michelle came up with 4 to 5. Joe came up with 4 to 5 as well. And Alan came up with 4 to 5. Okay, Joe came up with 4 to 5. Yeah, Joe, in that case, it doesn't matter really. You could have written it either way. They both mean the same thing. Okay, so congratulations on that one. Everybody was correct. The answer is 4 to 5. When we look at the problem, probably the quickest way of looking at it, I'm not going to go into the probability part where, I'm saying that, the probability of y is going to be 4/9. I'm not going to get into that part of it, because that's kind of lengthy. The best part of it is probably or probably the quickest way of doing it is for favorable. And this is less confusing. because the other way you end up doing it, but you end up cross canceling and still coming up with the same answer. And they're four favorable because there's four white marbles, and everybody seems to got this. So I don't want to do anything that's gonna confuse people with all that extra math. And then five unfavorable. Okay. And when we say five unfavorable, there are five that are not white. Okay. And what makes white favorable is because we ask, what are the odds in favor of choosing a white? So that's what makes the white ones favorable. So four favorable because there are four white marbles and five unfavorable. So it's going to be 4-5. So congrats to everybody. You guys did an excellent job with that. All right, so here's the next one. An ordinary die is a cube with the numbers 1 through 6 on the sides represented by painted spots. And they're just trying to describe to you what a die look like. And die is singular for dice, which is plural. If you got two or more, you got dice. If you got one, it's just a die. Imagine that such a die is rolled twice in succession and that the face value of the two rolls are added together. The sum is recorded as the outcomes of a single trial at a random experiment. Compute the probability of each of the following events. Event A, the sum is greater than 5. And then the second one is event B, the sum is not divisible by 6. Okay, so let's see if we can figure this one out. The sum is greater than 5 is going to be the first one. Oh, okay, Michelle. Okay, so let's see. Joe has 13 over 18 for the probability of event A and 1 over 4 for probability of event B. Okay, not a problem, Joe. Okay, Alan has 26 over 36 or 13 over 18 for A, and for event B, 7 over 36. Okay, how's everybody else doing? Yes, class ends at 4, so we got about 6 minutes. This is going to be our last problem for today. But we will be back tomorrow night from 8 to 10. Okay, while you guys are working on it, I'm going to go ahead and lay out all of the possible outcomes for these two consecutive die rolls, because that's going to take a little while. So say I'm going to put 1 and 1. I can come up with 1 and 2, 1 and 3, 1 and 4, 1 and 5, and 1 and 6. Okay, or I could come up with, let's see, 2 and 1, 2 and 2, and come up with 2 and 3. Okay, so I'm still identifying all the possible outcomes that could happen, with the rolling of a die. Okay, so here's all our possible outcomes. Okay, so the first one says that when you add them up, they've got to be greater than 5. Okay, well, when we look at this, we can see that everything that is greater than 5, and greater than 5 means 5 or higher. So what we're gonna see a boundary being created here. Let's see. So let's change the filler here. Okay, everything that's going to be greater than 5 is going to fall below this Mason-Dixie line. Okay, so everything that's going to be greater than 5 is going to fall below this line here. Okay, have a nice day, Paula. Okay, and so then we're just going to count them up. Okay, now we know there's 36 because 6 times 6 is 36. So we're going to count up everything that's greater than 5. And so, or we can count up everything that's less than 5 and then subtract that from 36. So we can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can say there are 10 that are equal to 5 or less. So we can say 36 minus 10 will give us 26. We could do it that way. Or we could say 1, 2, 3, 4, 5. And then we could go 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, uh, 21, 22, 23, 24, 25, 26. So at that point, we got 26 out of 36. Now we're going to simplify that by dividing both of these by 2. At the end of the day, they are fractions, and fractions always have to be simplified to the lowest terms. Okay, so that's our answer, 13 out of 18 for the first one. Okay, so we see that, Alan and Joe came up with these answers, so congratulations. That's a good job. Okay, now the second problem, I'm going to have to undo some of this stuff so I can get back to the second one. So I'm going to undo that. And then this is the last one for the day, definitely. Okay, the second one says that they have to be divisible by 6. Okay, so the sum is not divisible by 6. So what we want to do is figure out what does it mean by divisible by 6. So the numbers that are divisible by 6 are 6 and 12 in this case. We don't have to worry about 18 because nothing's going to add up to 18. So we just got to find things that are divisible by 6 and 12, And then we're going to subtract that stuff out because it's easier to find the stuff that is not as opposed to the stuff that is. So we're going to find everything that is 6. Okay, and so these are all 6s right here. And then we have to find 12 right there. Okay, so those are the numbers. 1, 2, 3, 4, 5, 6. So there are 6 that are divisible by 12. Okay. So the ones that are not divisible by 12, by 6 or 12, I'm sorry, there are 6 that are divisible by 6 or 12. So the ones that are not are going to be whatever's left over. So that's going to be 36 minus 6, which is going to be 30. So not is going to be 30. Okay. And let's see what the question said again. The question said, okay, the sum is not divisible by 6. Okay, so not divisible by 6 is going to be 30 out of 36. Both of these numbers can be divided by 6. And so that's going to give us 5 over 6 as, let me pull that back up there, 5 over 6. And I'm trying to see who came up with that answer. Well, actually, no one came up with 5 over 6. Okay, but that's our answer is 5 over 6. Okay, so at this point, we're going to conclude our go-to training. Go-to training was from 2 to 4. I will archive this go-to training and make it available on YouTube. Okay, so I'm going to go ahead and stop the recording at this point. Before we call it a day, does anybody have any